The United States Space Agency, NASA, is putting in a lot of effort to locate and monitor the asteroids that pose the greatest danger to Earth. Notwithstanding the fact that the performance of the agency is below par, Congress has mandated that it must meet certain standards. The DART mission of NASA created headlines a year ago when it successfully impacted Dimorphos, a small orbital companion of the larger Didymos asteroid. This measurable effect changed the orbit of Dimorphos, which ushered in a new era in humanity's abilities to defend itself against threats posed by the cosmos. The Double Asteroid Redirection Test, often known as DART, was a successful experiment that was designed to demonstrate that it is possible to crash a spaceship onto a very small asteroid. It is not yet clear whether or not this technique would be successful in protecting the Earth from a potential threat in the future. One unimportant point to make is that our knowledge of the character and origin of these threats is quite limited. Despite this, NASA is working to find a solution to the problem. How many other planets and asteroids orbit so near to ours? To put it more clearly, stray asteroids pose a serious risk to the continued existence of human life on our planet. The largest asteroids, defined as those with a diameter of at least 0.9 kilometers, have the potential to cause catastrophes on Earth that are on par with extinction levels. Yet, large asteroids are extremely rare and only hit the Earth around once every 500,000 years on average. The more numerous and smaller asteroids, those with a diameter of less than 1 kilometer, are the ones that cause the most concern, 0.6 miles. In spite of the fact that they are unable to wipe out the whole human population, they are nevertheless capable of obliterating a number of sizable cities and bringing about global tsunamis. The United States Congress came to the conclusion in 2005 that NASA required enhanced asteroid detection capabilities in order to fulfill its mission. The United States Congress mandates that the National Aeronautics and Space Administration, NASA, locate, track, and investigate 90% of all near-Earth objects, NEOs, with diameters more than 1,800 meters. In the event that such a big asteroid was to collide with Earth, the consequences would be exceedingly catastrophic. In the year 2020, NASA is expected to have successfully completed the NEO detection project. Yet, there is a catch. Despite the fact that the mandate was quite clear, Congress did not approve any more funding for NASA to carry out the instruction. The efforts of NASA are geared toward protecting the Earth. As the year 2020 got closer, NASA's inventive workers became innovative in order to meet the deadline. They emphasized new spaceflight flights rather than depending simply on ground-based surveys, which were both time-consuming and challenging to fund, and this helped them convince Congress of the necessity of planetary defense. This is effective. The DART program was given the green light for funding by Congress a full year before NASA even made its official request. With the DART satellite, the previously defunct spacecraft known as WISE, which had been sitting unused in space for a number of years, was given a new mission. The renamed equipment is now known as NEOWISE, Near-Earth Object Wide Field Infrared Survey Explorer, but it will serve as NASA's primary instrument for identifying potential threats to Earth in the near future. Around the time that this article was being written, NEOWISE and other ground-based telescopes had identified 8,59 near-Earth objects, NEOs, with a diameter of more than 0.9 kilometers, 10,398 NEOs with a diameter of more than 168 meters, and 31,247 NEOs of all sizes. This accounts for around 35% of the total number of NEOs that are predicted. But, while this statistic is useful, it is still a long way below the responsibility placed on Congress to detect 90% of NEOs. There are still quite a few potentially hazardous asteroids to find. As a direct result of this, NASA is speeding up the process of developing new programs and collaborations. For instance, the Legacy Survey of Space and Time, LSST, that will be a part of the soon-to-be-built Vera Rubin Observatory should be able to locate 90% of all NEOs that are wider than 300 meters, 1,100 feet. In the meantime, the project that would succeed NEOWISE and is currently known as NEO Surveyor was rushed through the process of obtaining funding permission without following the traditional paths for competitive proposal submissions. NEO Surveyor is expected to lift off somewhere around the year 2028, and its primary mission will be to carry out the NEO census that has been mandated by Congress. Despite the fact that these instruments will be able to find and monitor potentially harmful asteroids, they will fall short in one critical area, which is classification. In the not-too-distant future, observatories will have a minimal issue recognizing a speck of bright pixels as an asteroid and monitoring its movement for a few weeks in order to determine its orbit. On the other hand, doing an in-depth examination of the asteroid in order to determine its form, surface properties, and composition is a very different endeavor. It is vital to have an understanding of these properties in order to make an accurate risk assessment of an asteroid. The first observations of the asteroid suggest that a possible intersection of orbits is not the sole source of the potential danger posed by the object. An asteroid's anticipated orbit might be substantially changed depending on its specific form and luminosity. This is because the Sun heats the solar system in an uneven manner. We do not have complete knowledge of the danger that an asteroid may pose to Earth since we do not classify NEOs. The features of asteroids can teach us many valuable lessons. In the event that an asteroid does represent a danger to Earth, our first priority will be to investigate the asteroid's chemical composition. A significant number of asteroids are made up of shards of rock that is only tenuously held together by gravity. These rubble-bile asteroids are extremely difficult to destroy because, when they are struck, they behave like huge space cushions. Certain asteroids have an unusually high percentage of metals and are quite dense. Whether the asteroid was a pile of rubble or a dense mass of metal would have a significant impact on how a mission similar to DART would be carried out in order to save Earth from an asteroid collision. The composition of an asteroid is another factor that plays a big role in determining what would happen if an asteroid collided with the Earth. For instance, the asteroid may disintegrate in our atmosphere or burrow deep into the Earth's crust depending on its composition. A number of astronomers have put forth ideas regarding how we may improve our knowledge of the components that make up NEOs. A network of tiny satellites in low Earth's orbit, each equipped with visible and infrared sensors, may be used to continually monitor newly discovered NEOs and develop models of the surface compositions and structures of these objects. This is one of the ideas that has been proposed. Regrettably, it will take several more years until NEO observatories that are currently in the planning stages become operational and complete this research. Hence, until notice, you should continue to keep your fingers crossed.